Unit on electrochemistry with redox reactions. So we're going to take a look at reactions from last year in 3U, where we did total net and net ionic equations. So in the example here, we have a lead nitrate and zinc reacting to become zinc nitrate and lead. So this is a single displacement reaction. We can see some pictures here of what we would see happening during that reaction. So our molecular equation is PbNO32 plus Zn becomes ZnNO32 plus Pb. And if you remember from 3U, anytime we have anything that is aqueous, that means that it dissociates in water. So for our ionic equation, what we're going to do is take anything that is AQ and split it into its separate ions. So lead nitrate is made up of one lead ion and two nitrate ions. Now nitrate, we can look at the back of the periodic table, those extra tables that we have, and we have the list of polyatomic ions. And from there we can see that nitrate is NO3 minus. And if I work backwards for my crisscross, then I can see that lead is a 2 plus. And so same thing here, nitrate is a 1 minus, and so if I work backwards, that's a 1 there, which nitrate is a 1, and then that means zinc is a 2. So I have one lead ion, Pb2 plus. I have two nitrate ions, so 2 NO3 minus. 1 mole of solid zinc. And then that becomes 1 mole of zinc ions, 2 moles of nitrate ions, and for every 1 mole of solid lead. So if you remember here, for our total ionic equation, we took a look at anything that was the exact same on our reactant side and our product side. And that was called a spectator ion because it was no different when it was in the reactants from when it's in the product. So lead on the reactant side is a lead ion, whereas it is solid lead in the product side. So that's different. I have 2 nitrate ions in the reactants and 2 nitrate ions in the products as well. So that is going to cancel. And I have a solid zinc atom, and then a zinc ion, which is aqueous on the product side. So that is different as well. So the net ionic equation then is lead ions and zinc atoms react to become zinc ions and lead atoms. So we're going to take a look at what happened to each lead and zinc. So with lead went from being an ion to being an atom. So the charge changes from being a 2 plus to neutral or no charge at all. So the way for that to happen is that 2 electrons must have been gained. So a 2 plus charge plus 2 negative charges from an electron would give us a neutral overall. So we call this equation with the electrons included a half reaction because it's not the full reaction that is going on. When we look at electrochemistry, we refer to the different reactions going on as redox reactions. And so we're going to get into shortly reduction reactions and oxidation reactions, and they happen in conjunction with one another. So we look at those as sort of the 2 separate reactions that are going on at the same time. So we call those the half reactions. So the half reaction that is going on here is a lead ion and 2 electrons combine to make a lead atom. So 2 electrons are coming from somewhere, and we'll talk about where momentarily. 2 electrons are coming from somewhere, and they are joining with the lead ion, and then that is no longer charged, so it's now an atom. So with zinc, what happens is we started off with a zinc atom and it becomes a zinc ion. So there our charge goes from neutral or 0 to a 2+. So what happens there to end up with a charge of 2+ is 2 electrons must have left the zinc atom. So in this case, it loses 2 electrons. Now, we don't say minus 2 electrons. What we would do is we would add that in on the product side, that this is splitting into a zinc ion and 2 electrons. So our half reaction here is a zinc atom splits into a zinc ion and 2 electrons. So when we have a loss and a gain of electrons, this is when we are talking about redox reactions. The loss of electrons is called an oxidation reaction, and a gain of electrons is called a reduction reaction. And once again, these happen in conjunction with one another because one thing is going to lose electrons and the other thing will gain it. So oxidation reduction reactions happen together, and as a whole, we call a full reaction a redox reaction because both oxidation and reduction are occurring there. So in this particular example, the lead accepts electrons. So that went from a lead ion, it accepted 2 electrons to become a lead atom. So that undergoes what we call reduction because it gains electrons. It is called an oxidizing agent because by taking electrons, it allows something else to undergo oxidation, which oxidation is the loss of electrons. So whatever allows something else to undergo the opposite reaction is the agent. So this is where what undergoes reduction, so what gains electrons, in this case the lead ion, it is also the oxidizing agent because in gaining electrons, it allows something else to lose electrons. Zinc, on the other hand, undergoes oxidation. It loses electrons. So it is called a reducing agent because by losing those electrons, it is allowing something else to gain electrons. So this is where the agent, reducing and oxidizing agents, are opposite from the half reaction that a specific substance undergoes, so either an atom or an ion. So to help us remember those, we have a little mnemonic, Leo-Ger. So a loss of electrons is oxidation and a gain of electrons is reduction. Another one that people sometimes use is oil-Rig, and that is oxidation is a loss of electrons and reduction is a gain of electrons. So whichever one you want to use to help you, you're more than welcome to do so. Okay, so we'll take a look at an example. Write the balanced half reactions from the net ionic equation for the reaction of solid aluminum and aqueous iron 3 sulfate. State which reactant is being oxidized and which is being reduced, and identify oxidizing and reducing agents. Okay, so we have solid aluminum, so that's Al and solid, and we have aqueous iron 3 sulfate. So sulfate is SO4 2-, which means as we do our crisscross, iron is going to get the 2 charge from the sulfate and iron 3, so Fe3+. So sulfate is then going to get a 3, and that is aqueous. So we have a single displacement reaction. Aluminum is a metal, so it's going to replace the metal in iron sulfate. So that's going to leave me with solid iron and aluminum sulfate. So aluminum is a 3+, and that's going to get the 2 charge from sulfate, and then we're going to get a 3 coming over there, and that is also aqueous. So over here, I have 3 sulfates and 3 sulfates, so that's balanced. It's just my aluminum and my iron, but that's easy enough to balance. So I need 2 aluminums here and then 2 irons. Okay, so that's the first step, write out the molecular equation. Second step is to do the total ionic equation. So I have 2 aluminum, I have 2 iron atoms that have a charge of 3+, so I know that from here, iron 3, and I have 2 of them. And I have 3 sulfate ions. And then I have 2 atoms of iron, 2 aluminum ions. Aluminum is in group 3, so it's a 3+, and 3 sulfate ions again. So my 3 sulfate will cancel, which means my net ionic equation is 2 atoms of aluminum and 2 ions of iron 3 become 2 atoms of iron and 2 ions of aluminum. So we're going to split these into aluminum and into iron, into the half reactions. So I have 2 aluminum becoming 2 aluminum ions, and I have 2 iron ions becoming 2 atoms of iron. So what I need to figure out is which one is oxidation, which one is reaction. So where do the electrons fall on for each one? Is it in the reactants or the products? So here I have an overall charge of 0. So I have an atom which is neutrally charged, and then I have 2 aluminum ions which are each a 3+. So over here I have a 0, over here I have a 6+ total. So the 6 electrons on this side would neutralize the 6+ charge, which would leave me with an overall neutral charge. So I have 6 electrons here. And over here, I have 2 ions, each with a charge of 3+. So my overall charge in the reactants here is a 6+. It's 0 here, neutral for the atom. So a 6+ and 6 minuses, or 6 electrons, would end up neutralizing that. So those are the 2 half reactions. Now we can reduce these to 1, 1, and 3, and 1, 3, and 1. Oops. Okay, that's just quicker. So aluminum atom becomes an aluminum ion plus 3 electrons, and an iron 3 ion plus 3 electrons becomes an iron atom. Okay, so now we have to identify what is oxidation and reduction. So write half reactions, state what is being oxidized, what is being reduced, and then identify what the agents are. So we have Leo Gurr to help us out. So whatever is losing electrons is oxidation, and the one that is gaining electrons is reduction. So aluminum starts out as an atom and then becomes an ion, and because it's positively charged, it needs to lose electrons. So when I have my electrons in the products, it means that those were lost from what my reactant was. So this is the loss, which makes it oxidation. So the overall reaction, the half reaction, whoops, nope, that's not what I want to do. Okay, so my overall half reaction here is the oxidation reaction. Aluminum is what is getting oxidized. And it's the aluminum atom. And then what is getting reduced then, so the thing that is gaining electrons, is the iron 3+ ion. Okay, so this is the oxidation reaction. This is the reduction reaction. We also refer to them as oxidation reduction half reactions. The aluminum atom is getting oxidized. The iron ion is getting reduced. And the other thing we were asked for is, what is the oxidizing agent? And what is the reducing agent? And this is the thing that is backwards. So the oxidizing agent is the thing that allows for oxidation to happen. So it would be the thing that gets reduced. So the iron ion gets reduced. It gets reduced by gaining electrons, which means it is allowing the aluminum atom to lose electrons. So this is the oxidizing agent. The thing that gets reduced is the oxidizing agent because it allows for something else to undergo oxidation. And then that makes the aluminum atom the reducing agent because it allows for the iron ion to undergo reduction. So by losing electrons, the aluminum atom is providing electrons that the iron ion is then able to accept and undergo reduction. Some practice questions to work on. So these are from the old textbook, page 467, numbers 1 to 4, and page 468, numbers 5 to 8.